Hello and welcome. Today at Eaton's Power Systems Experience Center, we are delving into the world of reduced voltage soft starters, or RVSS for short. These devices are essential in motor control, and we'll explore the fundamental principles, features, and benefits they offer. Let's get started by covering a few basics. What is a reduced voltage soft starter? A reduced voltage soft starter, or RVSS, is an electronic device used in motor control. It is designed to start and control the speed of electric motors, providing a gradual increase in voltage to the motor for a smooth startup. This differs from traditional across-the-line starters, which apply full voltage to the motor instantly. Across-the-line starters are simple and reliable, but immediately applying full voltage to the motor draws a significant amount of inrush current. An RVSS reduces inrush current associated with motor startup for a controlled, gradual start. To understand why this is important, we must first understand inrush current and its negative effects. Inrush current is the maximum current draw that occurs when an electrical circuit is turned on, and is much higher than the steady state current that occurs when the motor is running at full speed. This high initial inrush current can cause damage to both your electrical system as well as your motor. Now let's take a look at a side-by-side comparison of the motor starting curves of an across-the-line starter compared to an RVSS. As you can see, across-the-line starters typically draw inrush current of 6 to 8 times the motor's full load amperage upon startup. This can cause voltage sag as well as unwanted stress and strain on your mechanical system. Now let's look at the RVSS motor starting curve. See that gradual ramp up? This is signifying a reduction of inrush current, which can improve the lifespan and reliability of your motor system, as well as mitigate voltage drop upon startup. So how does the RVSS achieve this? Soft starters use a series of thyristors, or silicon-controlled rectifiers, to reduce the initial voltage applied to the motor. SCRs act as gates that let small amounts of current through by switching between on and off states. Here on this 3-line diagram, we can get a better look at the sequence of operations for an RVSS. First, the main contactor closes, and current passes through the SCRs as voltage is ramped up per program values. After ramp-up is complete, the bypass contactor closes, then the SCRs are turned off for a closed transition. From this point, the motor runs the same as a full voltage or across-the-line starter. Soft starters can also reverse this sequence if a soft stop is needed. Note that the SCRs are only on during starting or stopping, and therefore no additional enclosure venting or fan cooling is required. The bypass contactor also allows for across-the-line starting in the unlikely event of problems with soft start components. There are also a variety of soft start control functions, which can be programmed to meet the starting needs of your specific application. Some of the most common methodologies are kickstart, which provides an initial boost of current to overcome motor and system inertia. Ramp start, in which the operator sets the initial starting torque value, then raises the torque to full voltage. Current limit, which limits the maximum starting current and is used in long start time applications. Soft stop, which provides extended stopping time and is used in high friction load applications where a sudden stop may cause system damage. A good example of this use case is to mitigate water hammer effects in pump processes. Now that we have a good understanding of soft starters and how they work, let's discuss some of the benefits of RVSS in motor control. Soft starters minimize peak current through controlled ramp-up. This is particularly beneficial in applications where frequent starts and stops occur. Voltage drop is a common challenge when starting large motors in areas where there are weak power systems. By providing a gradual soft start that reduces inrush current, an RVSS can mitigate voltage drops, and in some cases may even be required by your utility for motor operation. I mentioned earlier that an RVSS is also capable of performing a soft stop. This eliminates water hammer pressure surges on pump systems, preventing unwanted strain on pipe and valve infrastructure. RVSS extends the lifespan of motors and connected equipment by reducing mechanical stress, minimizing wear and tear, and providing enhanced motor protection. Finally, RVSS is an economical choice for motor control. Within the motor control world, there is often discussion on utilizing soft starters versus variable frequency drives for a given application. Soft starters are an ideal and economical choice in processes that require speed and torque control only during your startup and ramp down periods, whereas drives are a premium offering for applications where complete speed control is required during your start, stop, and run cycles. Reduced voltage soft starters are a crucial component in motor control. Their versatility makes them suitable for a wide range of applications, from pumps and fans to crushers and compressors. Now that we have a well-rounded view of soft starters, let's take a look at the features and benefits of Eaton's latest medium voltage offering, the Ampgard RVSS. The Ampgard RVSS is the first soft starter in the market meeting UL 347 medium duty ratings. This UL medium duty rating is defined as 3 30-second starts per hour. To put that into perspective, our previous MV4S soft starter was rated to 1 start every 4 hours. This marks a huge uptick in reliability without compromising on other power ratings. It also features a cyber-secure user interface, as well as roll-in, roll-out SL contactors for both the main and bypass. In the event of an emergency situation, you can run the Ampgard RVSS on bypass operation by toggling a simple selector switch. No need to move or reconnect power cables. The draw-out SCR truck is comprised of a modular design with 3 power poles, which can be independently withdrawn and replaced for ease of maintenance. Finally, we have an exclusive pre-start check system that detects a range of potential fault conditions before applying medium voltage. This offers a stress-free startup process and ensures safe and reliable operation. We hope this video gives you a good look into the world of soft starters and their role in motor control. To learn more about how Eaton can support your motor control needs, visit us at Eaton's Power Systems Experience Center.